Hi friends, let us try to understand about image formation by concave mirrors in this class. So before going to the class, we need two things to be understood. The first thing is what is meant by a ray diagram, and the second thing is the rules for the image formation by concave mirrors. So about the first thing, what is a ray diagram? So if we consider a point source, what is the meaning of a point source? If there is a source which is of the size a point, if there is simple a point present, from that point source infinite number of light rays will come. From that infinite number of light rays, if you try to understand about all the infinite number of light rays, how they behave, it becomes very difficult for us to understand how the images are formed. So we consider that only two rays are coming from the point source or the source, and we are trying to understand how the light rays are behaving after reflection. If we draw a diagram for it, that is called as a ray diagram. So once again, what is a ray diagram? If we consider a point source, infinite rays will come from it. But if you consider that only two rays are coming from a source, and if you understand how the two rays are behaving after reflection, that means where they are meeting after reflection, if you draw a diagram for it, that is called as a ray diagram. So next, the second thing is what are the rules for the image formation by concave mirrors. So if you see here, these are the rules for the image formation by concave mirrors. So how a ray will reflect after reflection, how the light ray will pass is understood by us by the rules. Now if there is a light ray, we all know that a line which is joining pole and center of curvature is called as principal axis. Now if there is a light ray which is passing parallel to the principal axis, that ray after reflection will always pass through the focus. That is rule number 1. So what is the first rule? If there is an incident ray, how you can identify that this is an incident ray? Because you can see the arrow is marking towards the mirror. This is going towards the mirror. So if the incident ray is parallel to the principal axis, then the reflected ray, this is the reflected ray because the arrow is marked away from the mirror. So this is the incident ray, this is the reflected ray. If the incident ray is parallel to principal axis, the reflected ray always passes through focus. That is rule number 1 for the image formation by concave mirror. If the incident ray is parallel to the principal axis, the reflected ray passes through focus. And what is rule number 2? If the incident ray is passing from the focus, the incident ray is passing from the focus, it goes parallel to the principal axis. Just by seeing the arrow marks, you should be able to identify which is the incident ray and which is the reflected ray. Now if you see here, for this ray it is marked towards the mirror. So this is the incident ray and this is the reflected ray. If the incident ray is passing through the focus, then it goes parallel to the principal axis. If you see the diagrams, both almost mean the same, but this is the reverse of this and this is the reverse of this. So light follows this, which is called as principle of reversibility. Means if the light ray is parallel to the principal axis, it passes through focus. And if the light ray is passing through focus, it goes parallel to the principal axis. So these are the rules 1 and 2. Now coming to the third rule, if there is a light ray passing through center of curvature, if there is a light ray passing through center of curvature, it rebounces back. Means if the light ray is going like this, it comes back again in the same way, same path how it has gone. So it rebounces back. If there is a light ray passing through center of curvature, it rebounces back. That is rule number 3. And the rule number 4 is, if the incident ray is making an angle, a certain angle at pole, with the same angle it reflects back. That means angle of incidence is equal to angle of reflection. So these are the 4 rules that we should understand before we proceed to the image formation by concave mirrors. Now when you try to understand the image formation by concave mirrors, we should understand that when the object is changing its position, the image also will change its position. When the object is changing its position, the image will also change its position. So now let us try to understand the first case. So what is to be understood very clearly here is where the object is kept. If the object is kept at that place, where is the image formed? This is the position of the object, this is the position of the image, and what is the nature of the image? Every image has a nature of its own. Means we have already discussed it in our previous classes. How do we define the nature of an image? What are the words we use and what is the meaning of that? So we need to understand about these three things very, very clearly for the image formation by concave mirrors. Now in the case 1, if you consider that the object is very far, when the object is very far, the rays which are coming are infinite, and generally the rays are parallel to the principal axis. So if there is a light ray which is parallel to the principal axis, according to rule number 1, if it is parallel to the principal axis, it passes through focus. So if it is parallel to the principal axis, it passes through focus. This is ray number 1. So in every ray diagram we have two rays, because we are trying to understand the behavior or where the image is formed, how the image is formed, just by considering two rays. Now this is the first ray, ray number 1, which is parallel to principal axis passing through focus, and this is the second ray, which is ray number 2, which is parallel to principal axis. This is also passing through focus. Now both the reflected rays are meeting at focus. When both the reflected rays are meeting at focus, what is formed? An image is formed, because here the object is of a very big size. Because this is coming from infinite, you can consider it as what we can sun or any object which is far. So from that, if the image is coming from that, means if the rays are coming and the reflected rays are meeting at focus, if this is the size of the object, this is the size of the image. Where the reflected rays are meeting almost on the focus, near the focus. So the size of the image is very small. So let us try to understand what is the position of the object, what is the position of the image, what is the nature. What is the position of the object? We consider that the object is very, very, very far. So we say that the object is at infinite. The object is at infinite. So where is the image formed? Image is formed at focus. Image is formed at focus. Now let us try to understand what is the nature of the image that is formed here. Now the reflected rays are meeting. So we understood that there are two types of images. One is virtual and one is real. Virtual images and real images. Real images are formed when the reflected rays are meeting. Here real images means the reflected rays are meeting. So the image that is formed is real. Now when the reflected rays are meeting, real always goes with inverted. It is always inverted. Real and inverted image is formed, and the size of it is very, very, this is the size of the object and this point is the size of the image. If this is the size of the object, if this point is the size of the image, you can understand how the image is. The image size is very, 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 very small when compared to the size of the object. So we say that the image is highly diminished. So the image is highly diminished. So when the object is at infinity, the image is formed at focus. And how the image is formed? What is the nature of the image? It is real, inverted, and highly diminished image is formed. Now coming to the second case. So in first case we have kept the object at infinity. Now we are bringing the object a little close. Let us suppose if we are keeping the object beyond C. This is C, this is P, F and C, and C, this object is beyond C. So we can write that the object position is beyond C. Now when beyond C, let us try to understand how the rays are behaving. You can see the first ray going parallel to the principal axis, If it is going parallel to the principal axis, it always passes through focus. So you can see this is the incident ray and this is the reflected ray passing from focus. And the second ray, you can see it is passing through center of curvature. So according to this rule 3, if it is passing through center of curvature, it rebounces back. So if it is passing through center of curvature, it rebounces back. It is going like this. This is the incident ray and it goes like this. This is the reflected ray. So now you can see here, observe here that both the reflected rays are meeting. This is one reflected ray. This is the reflected ray for ray 1 and this is the reflected ray for ray 2. These both rays are meeting at this point here. So here an image is formed and the image is represented by the blue line, which is A dash B dash, and the object is represented by the black line AB. So now if the object is beyond C, the image is between F and C. So if the object is beyond C, the image is between F and C. Now how is the size of the image? You can see the object is bigger when compared to the size of the image. So the object is bigger when compared to the size of the image, means image is smaller. Image is smaller, we say that the image is diminished. The image is diminished. And where is the object? Object is beyond C. Where is the image? Image is between F and C. Now how is are the reflected rays meeting? Yes, the reflected rays are meeting. If the reflected rays are meeting, what kind of image is formed? Real and inverted image is formed. So 3 points to be understood for us when we are trying to understand about image. Where is the image formed? And is the image real or virtual? Or what is the size of the image? These 3 points are to be understood regarding an image, and these all 3 points are dependent on where the object is. So if the object is beyond C, the image is between F and C and the image is real, inverted and diminished. Now coming to case 3, now here if you see the object is at C. Where is the object? The object is at C. If you are placing the object at C, where is the image? Now you can observe the 2 rays. The first ray going parallel to the principal axis. If it is going parallel to the principal axis, it passes through focus. This is going parallel to the principal axis, passing through focus. This is ray number 1, which is going like this and coming. Now this is ray number 2. This is passing through focus. So if it is passing through focus, according to rule 2, you can see if it is passing through focus, it goes parallel to principal axis. This is passing through focus and this is going parallel to the principal axis. So this is the incident ray and this is the reflected ray. It is going towards the mirror and this is going away from the mirror. These 2 rays are the reflected rays for ray 1 and ray 2. These 2 rays are meeting at this point C. So where is the image formed? Image is also formed at C. When the image is also formed at C, what is the size of the image? You can see both are of the same size. So what is the image formed? The image formed is of same size. The image formed is of same size. And where is the object? At C. Image is at C. Are the reflected rays meeting? Yes, the reflected rays are meeting. So it is real, and you can see object is like this and image is upside down. Image is upside down. So if the image is upside down, we call it as inverted. In the second case also you can see the image is upside down because the first ray is this and second ray is this. So you can see the image is inverted. So first case, real, inverted and highly diminished image is formed. Second case, real, inverted and diminished image is formed. Third case, real, inverted and image of same size is formed. First case, object is at infinity. See, if you observe, there is a pattern in this. In this, first the object is at infinity, next it is beyond C, and in the third case it is at C. So if the object, if you consider this as infinity, first infinity, then beyond C, then at C. And in the same way, what is happening to the object? The object is coming close to the mirror. And if you see observe the mirror image, first it is at F, then it is between F and C, third it is at C. Means what is happening to the image? The image is moving far from the mirror. And here in nature also, first case it is highly diminished, second case it is diminished, third case it is of same size. So these are the first 3 cases of image formation by concave mirrors.